Welcome to the deep dive. Our mission here is, well, pretty simple, to give you that shortcut to being really well informed.
Yeah, we take these huge stacks of sources, sometimes dense, complex stuff.
Absolutely. And we boil it all down to the essential, the fascinating nuggets you actually need to understand what's happening on the cutting edge.
And today, we're doing something a bit different.
We're not just looking at a successful business model. We are basically handing over the entire technical blueprint, the actual roadmap, to copy a, frankly, shocking automated content empire.
It's pretty wild when you see it laid out.
It really is. You come here to gain knowledge quickly, thoroughly. And this deep dive, it delivers a masterclass in automated scaling. Our subject today is the architecture behind a specific, high-earning, completely faceless YouTube channel. It does motivational content.
Right. Motiversity. That's one the source focuses on.
Exactly. Motiversity, a channel that posts, what, almost daily?
Pretty much, yeah. Daily or close to it.
And according to our sources, it generates something like $38,000 a month just from Google AdSense.
Just AdSense. And pulling in over 5 million views to do that, it's significant.
It's huge. And most people, creators, they look at that kind of output, a daily, polished, long-form video, and they just assume, okay, you need a whole team, right? Editors, scriptwriters.
A small army, yeah. That's the usual assumption.
But the core insight, the really stunning thing from this blueprint is that basically all of that work, it's now automatable.
Completely. Our sources detail the exact step-by-step system built using AI orchestration, specifically designed to copy that successful publishing rhythm.
So this is more than just a workflow diagram.
Oh, much more.
Yeah.
It's, like you said, the architecture, the definitive architecture of an automated content empire. And our deep dive today, it's focused entirely on unpacking that precise AI automation system built using N8N.
N8N. We should probably emphasize what that is again.
Coined. Yeah, N8N. It's this really powerful, flexible, no-code or maybe low-code orchestration tool. Think of it as the central brain, the conductor.
Okay. It handles everything, right from the start idea generation all the way through scripting, generating instructions for visuals, doing voiceovers, rendering the video, and this is crucial, hands-free uploading straight to YouTube.
Wow. Okay.
And the main challenge, right, the thing this specific blueprint really cracks is consistency.
How so?
Well, how do you make sure a no-code tool, juggling all these different APIs and services, can consistently crank out polished, long-form videos and run 24/7 without someone having to poke it all the time?
Right, without breaking down or getting flagged for, like, spammy content.
Exactly. This system essentially creates an AI agent. It publishes content, all while the channel owner, the human, just focuses on the strategy, the high-level stuff, maybe quality control.
So the human effort shifts from doing the grinding work.
Totally. Shifts entirely from tactical, editing this clip, uploading that file, to strategic, thinking about the prompts, the overall direction.
Okay, let's try and visualize this. Give us the rapid end-to-end view, because it sounds like a lot of moving parts. It is, but it flows logically.
Yeah.
So imagine, it starts not with a person clicking go, but with a timer, a schedule trigger in N8N.
Automated start. Okay.
That trigger tells the system, hey, look for ideas. And it looks in Google Sheets, where they're all structured neatly.
Google Sheets, right, the database.
Precisely. N8N grabs one idea row, sends the key info, like the title inscription, off to the AI. The source uses Gemini here.
The AI part, generative AI.
Yep. Gemini then generates a structured storyboard. Scene-by-scene instructions, what to say, what to show.
Not just a script, but like visual cues, too.
Everything. Voiceover text, image prompts, style notes. Then that structured data package gets sent to a specialized rendering service. The blueprint uses something called JSON to video.
JSON to video. Okay, haven't heard of that one.
It handles the heavy lifting. Takes the storyboard, generates the images, synthesizes the voice, adds the background music you've chosen, stitches it all together.
Into the final video file.
Exactly. And then, the final step, N8N takes that rendered video file as binary data and pushes it directly to YouTube using the API. Uploaded. Done.
Concept to published video. Wow. All automated, governed by this N8N flow.
That's the picture.
Okay, before we dive into the weeds of each step in that flow, we need to talk basics. The setup. What do you absolutely need in place first?
Right, foundations. You need 3 essential credentials set up within N8N before you can even start building this.
Okay, number 1.
First, you need your Gemini credentials, or whatever LLM you choose, but the source uses Gemini. This lets N8N talk to the AI, authenticate, make requests. That's the creative engine, really.
Makes sense. AI connection. Number 2?
Second, Google Sheets credentials. This isn't optional. N8N needs to read the ideas, obviously, but also update the status, mark things as done, log errors.
So it's the system's memory and, like, its logbook.
Perfectly put. It's permanent memory and ledger.
Got it. And the third one?
Finally, YouTube credentials. That's the last mile, right? This allows N8N to actually upload the finished video straight to your channel, hands-free.
Okay. Gemini, Google Sheets, YouTube. Connect those three, authenticate them in N8N.
And you've basically laid the groundwork. The foundation is there for this automated content machine.
All right, foundation laid. Let's get into the flow itself. Section 1, content foundation, ideas and scheduling. Where does it really begin?
So the very first, and you could argue the most critical strategic choice in this whole blueprint, taking the human out of the loop for starting the process.
Removing the click to start button.
Exactly. If you, the owner, have to manually trigger it every single time you want a video, well, you lose that whole 24/7 high-volume advantage. The real power, the efficiency, it hinges on reliable passive scheduling.
Okay, so how do you achieve that in N8N?
It starts with the very first node. It's called the schedule trigger node. Simple name, powerful function.
The alarm clock for the factory.
That's a great way to put it. Instead of you hitting execute, you set it to fire automatically. And for this blueprint, aiming for that Modiversity style output.
Daily videos.
Yeah, high volume. You set the trigger interval to hours, and you set the number of hours between triggers to just 1.
1 hour, so it runs every 60 minutes.
Every 60 minutes. It kicks off, ready to look for work, constantly scanning for new ideas to process.
And there's a little detail you mentioned for consistency.
Yes. Small thing, but elegant, like you said. You set the trigger at minute parameter to 0.
0.
Why 0 specifically?
Predictability. It just guarantees the workflow fires precisely at the top of the hour. Every hour. On the dot. No drift.
Okay. So set that, activate it, and the pipeline is just running. Checking for ideas while you're sleeping, eating, whatever.
That's the definition of passive scaling right there.
Okay, trigger fires hourly. Now what? It needs fuel. It needs an idea. Exactly. The machine immediately needs something to work on. So the next step is accessing those ideas. And this is why Google Sheets is mandatory, not just, nice to have.
It's the data repository.
Right. It provides structured rows, a queue of work for the workflow to pull from, one at a time, every time it runs. And that word, structured, is critical.
Why so critical? Can't it just take a rough idea?
Not reliably. If the input isn't highly structured, consistent, the downstream AI steps, they'll get confused. They'll produce garbage or inconsistent output. The rendering process will likely fail. The machine needs clean, predictable data every single time.
Okay, we need to pause here then. Emphasize this input structure. This isn't just a brainstorm list in a sheet.
No way. The source material is very specific about what the workflow needs. And honestly, the most efficient way to get this started, often it's using another AI prompt before you even get to N8N.
Like ask ChatGPT or Gemini to set up the table.
Exactly. Prompted to generate a table structure with all the necessary columns already defined, maybe even pre-populated with some initial ideas if you want. Get the structure right from the outset.
Okay, let's walk through those columns. What absolutely has to be in this Google Sheet 1?
Right. The building blocks. First, an ID column. Just a unique number starting at 1 increments. Lets the system target a specific row later for updates. Simple but necessary.
Got it. ID.
Then the creative stuff. The idea column. This is your short, punchy YouTube title, the hook.
Okay.
Next, the caption column. This holds the longer text. Think of it as the video description that will eventually go on YouTube, or maybe the source text the AI will expand upon.
Title and description fodder. Makes sense.
Then, really important for consistency, style guides. You need a channel style prompt. Just 5-10 words describing the overall vibe. Cinematic, 4K, dark motivational, something like that.
It sets the visual mood.
Exactly. And paired with that, a character style prompt. This defines a unique visual element or character look that matches the topic. The AI image generator will use this for every visual it creates for that video. Consistency again.
So you get a consistent look across the whole video, not random images.
Precisely. Keeps it professional, branded.
Okay. ID, idea, caption, channel style, character style. What else?
Finally, the crucial tracking columns. The bookkeeping for the machine. First, production status. You initially set this to for production. That's the flag the hourly trigger is looking for.
The ready to go signal.
Yep. Then final output, leave this blank to start. This is where N8N will eventually paste the URL of the finished video.
Proof of completion.
Right. Publishing status. Just set this as pending initially. And lastly, an error log column. Keep it blank. If something goes wrong later, The system will write the error message here.
So it documents its own failures.
Yep.
Useful for debugging.
Incredibly useful. So you get this whole table structure defined, populate it with ideas, and paste that directly into sheet 1 of your Google Sheet. That's your input queue.
Okay. Sheet 1 is loaded. The scheduled trigger fires. What's the very next node in N8N?
It connects straight to N8N's Google Sheets node, configured for the get rows operation. Time to fetch an idea.
But wait, if there are, say, 10 ideas ready, does it grab all 10?
Good question. No, that would be inefficient. Waste resources, potentially overload the rendering API downstream. So you apply crucial filter logic within the Google Sheets node.
Filter logic. How
You tell it. Only get rows where the production status column equals literally for production.
So it ignores rows marked done or error or anything else.
Exactly. Only grabs fresh, ready-to-go ideas, keeps the pipeline clean.
But what if multiple rows are marked for production? Does it grab the first one it finds?
It could grab multiple by default, which we want to avoid.
Yeah.
So there's another essential toggle in the NA and Google Sheets node options. You must turn on the option to return only the first matching row.
Only the first one. So one run, one idea. Guaranteed.
Guaranteed. One clean, unique input for the workflow to process for that hour. Then next hour, if there's another 4 production row, it grabs the next first one, keeps it sequential and manageable, prevents duplicates, prevents overload. Critical engineering detail.
Okay. Single row retrieved. We have our idea, title, caption, style prompts. What's the next big step? Building the actual story, right?
Precisely. You've got this single structured idea row now loaded into the workflow's memory. But that row itself isn't a video script. It's just the seed.
Right. It's the title, the description, the style guides, not scene 1, scene 2.
Exactly. So the next massive hurdle is translating that raw input into a usable scene-by-scene script or storyboard. You can't just throw the title at a video renderer and hope for the best.
It needs explicit instructions for every part of the video.
Explicit structured instructions. This is where the creative engine kicks in, the part that replaces the work of a human scriptwriter or storyboard artist.
And how does N8N handle that? What's the node?
It uses the LLM chain node, large language model chain. This node acts as the creative architect.
Okay, and it uses Gemini in this case.
Yes, it takes the video title and the description pulled directly from that Google Sheet row we just retrieved and feeds them to Gemini via the credentials you set up earlier.
And ask it to write a script.
Essentially, yes, but with a critical twist focusing on consistency. The source material stresses this. You must configure the LLM chain node to require a specific output format.
What does that mean, specific format?
It means you force the AI to respond not with just, a block of narrative text, but with highly structured data, like a JSON array or object, machine readable.
So it's not just chatting, it's delivering data in a predictable structure.
Exactly. It's the organizational gatekeeper for the creative part. The prompt you give the AI within this node is key.
The system prompt, right, setting the stage for the AI.
Yes. If you were doing that dinosaur channel example, the system prompt might frame the model like, you are a YouTube content generator specializing in dinosaur facts. Create fast-paced, educational narratives.
Okay.
The inputs are the title and description from the sheet, but the task is very specific, very constrained. Create a structured storyboard, broken down into exactly 15 sequential scenes.
15 scenes? Why 15? Is that arbitrary?
Doesn't seem to be. The source suggests it's a strategic choice. It mimics the typical pacing and sort of the viewer retention patterns of high-performing YouTube videos. Long enough for substance, short enough to keep attention.
Okay, pacing strategy. And what's the structure within those 15 scenes?
Also very specific and non-negotiable for the AI.
Yeah.
Scenes 1 to 3 are the intro. Gotta have a strong hook, set up the premise immediately, grab 'em early.
Hook 'em fast. Makes sense.
Scenes 4 through 11 form the main body. This is where the educational content, the storytelling, the core value gets delivered. Needs good pacing here to maintain interest.
The meat of the video.
Right. And then scenes 12 through 15 are the conclusion. Wrap things up, summarize maybe, and critically, include a specific call to action. CTA. Tell people what to do next, subscribe, watch another video, etc.
Intro, body, conclusion CTA. Standard structure, but enforced on the AI.
Enforced is the key word, and it needs more than just the voiceover text for each scene.
What else does the AI need to generate per scene?
For the downstream rendering to actually work, each of those 15 scenes needs a whole package of metadata. We need the scene number 1, 2, 3. The full voiceover text, the exact words to be spoken. The topic focus for that specific scene like a keyword. A detailed description of visual style for that scene. The character prompt, remember that consistency prompt from sheet 1. It uses that plus scene specifics. And finally, the type of audio, needed background music fade, specific sound effect, just voice.
Wow, okay, that's a lot of detail per scene. Voiceover, topic, visual style, character prompt, audio type, all generated by the AI for each of the 15 scenes.
All generated, and crucially, the LLM chain node must be told to return only this structured data, typically as an array of 15 scene objects. No extra chat, no, here's your script, just the clean data.
Why so strict on the no extra text?
Because the next node needs to parse this perfectly. Any extra conversational text from the AI could confuse the parser and break the workflow. Strict adherence is vital for automation.
Okay, so the AI generates this structured 15-scene storyboard. What happens right after that? Do we just trust the AI got it right?
Good point.
Yeah.
No, we need quality control. Even a well-prompted LLM can sometimes, hiccup or deviate slightly from the requested format.
Right.
So the very next node is the structured output parser. Think of this as the machine's proofreader or quality check.
What does it do?
It takes the raw response from the LLM chain node and verifies that it perfectly matches the expected structure. Then it converts that verified response into clean, usable data for the rest of the workflow, typically that clean array of 15 scene objects.
How does the parser know what structure to expect?
You give it a template, an example schema. You can actually ask the AI, maybe in a separate chat, to generate a sample JSON schema representing one scene object with all those fields we just listed. Scene ID, voiceover text, image prompt, topic focus, audio style.
So you provide the parser with the blueprint of what a correct scene object looks like.
Exactly. You feed that schema into the structured output parser node. It then checks if the AI's output matches that schema precisely. If it doesn't match, the flow stops, diverts to the error handling path we'll discuss later.
Okay, so it enforces the structure after the AI generates it. Smart.
It's a crucial validation step. And the aha moment here, the reason this structured approach is so powerful for scaling.
Yeah.
Because the formatting rules are so strict and the parser acts as that final gatekeeper, the next steps in the process, the ones that actually build the video, can reliably pull the narration for scene 5, the image prompt for scene 8, the audio cue for scene 12. They can grab exactly what they need from this structured data without any guesswork or errors.
You've successfully turned a simple idea into a perfect, segmented, actionable blueprint for the video renderer.
Precisely. We have the story, the structure, the scene-by-scene instructions. Now, we need the polish.
Yeah.
The assets, music, and visuals.
Right, because just having the script and image prompts isn't enough for that professional feel. You mentioned Motiversity looks polished. Background music is a huge part of that.
Absolutely huge.
Yeah.
No pro video feels complete without it. So to manage these reusable assets music, maybe intro clips, we need another layer of organization. The blueprint recommends setting up a secondary sheet in your Google Sheets workbook. Let's call it Sheet 2.
Sheet 2, dedicated to assets.
Dedicated to reusable assets, yeah. Think of it as the asset library ledger. It ensures you have consistent, high-quality background tracks and maybe intro visuals ready to go for any video the system decides to make.
Okay, what columns do we need in this Sheet 2?
It's simpler than Sheet 1. The source details 4 key columns here. First, audio list. This will hold the URLs, the web links to all your available background music tracks.
URLs, not the files themselves. Got it.
Second, a column called To Use. This is where the magic of randomization will happen later, using a formula. Leave it blank for now. Third, randomized audio. This will just confirm the final selected audio track URL. And fourth, intro video. This stores the URL for a reusable intro clip if you want one.
Okay, audio list. To use, randomized audio, intro video. But where does the actual music come from? We can't just use any pop song, right? Copyright.
Oh, definitely not. Copyright is a killer for automated channels. Since the goal is high volume and avoiding strikes, the source strongly recommends generating your own bespoke audio.
Generating audio? How?
Using an AI music generation service. The source mentions Suno.com as an example, but there are others. You give it a prompt based on the video's topic or mood-inspiring cinematic track, epic motivational hip-hop, whatever fits your channel.
And then it generates a unique music track.
Yeah, pretty convincingly these days. You download the results, usually as MP3 files. And here's a strategic tip from the source. Generate at least 2 different suitable tracks per topic or mood.
Why 2?
Variety. If you use the exact same background track on hundreds of videos, that could potentially get flagged by algorithms as repetitive. Having 2 or 3 options per mood that the system can randomly pick from adds a simple layer of variance. It's a smart, subtle move.
Okay, generate a couple of MP3s using Suno or similar. But you said Sheet 2 needs URLs, not files. How do we bridge that gap? My MP3s are on my computer.
Right. Those local files are useless to the N8N workflow running in the cloud. They need to be hosted online, accessible via a stable URL. And this is another place where that JSON to video service comes in handy.
Rendering service. It does hosting, too.
It has an asset library feature. You can upload your generated MP3s directly into your JSON to video account, usually within a specific template's asset section. Once uploaded, it gives you a shareable, persistent URL for that hosted audio file.
Ah, okay. So upload the MP3 to JSON to video, get the URL.
Copy that URL and paste it directly into the audio list column in Sheet 2. Do that for all your generated tracks. Now N8N can access them.
Clever. Using the rendering platform for asset hosting. Okay, what about that intro video column? Same idea.
Pretty much the same principle. If you want a standard professional intro clip, like a 5-second logo animation or a relevant stock video snippet, you can add that too.
How do you get that into the system?
Again, using the JSON to video template's asset editor. It often integrates with stock footage libraries like Pexels or Pixabay directly. So within the JSON to video interface, you can search for a relevant clip, say, dinosaur roaring, if that's your theme.
Find a good one.
Save it to your assets within JSON to video. It gets hosted, just like the audio. Copy its hosted URL.
And paste that URL into the intro video column in Sheet 2.
Exactly. Now you have reusable hosted background music and an intro clip, all referenced neatly in Sheet 2, ready for the automation.
Okay, assets are hosted, URLs are in Sheet 2. Now, you mentioned randomization. How does the system pick which music track to use for a specific video?
This is the second critical part here, automated variety. It's surprisingly low-tech but effective. It happens right in the Google Sheet itself.
In the sheet, not in N8N.
Nope, in the sheet. In that to use column, we left blank. You insert a spreadsheet formula. Something simple, like a function that randomly selects one URL from the list of URLs you put in the audio list column on that same row.
So like index A2.A5 ram between 1, counto A2.A5 or something similar.
Exactly that kind of thing. A standard Google Sheets function. It's brilliant because it ensures subtle variation without needing complex logic or extra API calls in N8N. Each time the sheet recalculates or you trigger a recalc, it might pick a different track.
So for the video being made this hour, the formula picks one random track from the available options.
Precisely. Then to lock in that choice for the current run, the blueprint suggests having a status mechanism. Maybe the formula outputs the URL and you have another column, say randomized audio status, where you manually, or via another script, though the source implies manual batching here, mark the chosen track as final.
Mark it as final in the sheet. Why?
So that when NAN runs his next Google Sheets node to fetch the assets from Sheet 2, it can filter again.
Oh, okay. So back in NAN, you add another Google Sheets, get rows node, this one pointed at Sheet 2.
Right. And you configure its filter to only retrieve the row where your status column, e.g. randomized audio status, is marked as final.
Got it. So it ignores all the other audio options and just pulls the single randomly selected confirmed track for this specific video render job.
Exactly. It locks in the choice, guarantees uniqueness for that run, and ensures the workflow only proceeds with the one confirmed audio track URL. Asset management and randomization handled. Now we're ready to actually build the video.
Okay, this feels like the main event. We've got the 15-scene structured storyboard from the AI. We've got the randomly selected background music URL, maybe an intro clip URL. All the pieces are ready.
They are. This section is the industrial core, like you said. It's the moment where all those carefully prepared components get packaged up and sent off to the factory floor of the rendering engine.
We're telling the video factor exactly what to build.
Precisely. And this starts with another HTTP request node in N8N. This is how N8N talks to external services like the JSON to video API.
Okay. And since we're asking it to create something new, a new video.
The HTTP method is set to post. We are posting a new render job request to the specific API endpoint provided by JSON to video.
How does it handle authentication? Does the rendering service know it's my N8N workflow calling?
Yeah, you need to authenticate.
Yeah.
Typically, this is done using a generic credential type in N8N. You'd add an HTTP header, usually XAPI key or something similar, and put your unique API key from JSON to video in there.
Standard API key authentication.
Got it. And you also set the content type header to application JSON, because we're about to send a big blob of structured JSON data in the request body.
The payload, right. This sounds like the complicated part. What exactly goes into this JSON payload?
It is the most complex part, data-wise. This payload is the complete instruction manual. The source notes it's often best to draft this structure initially with AI help, like asking ChatGPT to create a template based on the JSON to video API docs. just to ensure the syntax is perfect.
Okay, so what key information needs to be mapped into this JSON?
Several critical parameters. First, the template name or ID. You usually get this from the URL of the master template you set up into JSON to video, the one where you uploaded assets.
Tells it which template shell to use.
Right. Then the voice model. The source mentions setting it to Azure and specifying a particular voice ID. This ensures the narration voice is consistent across all your videos. Brand voice consistency.
Smart. What else?
The image model. The source specifically calls out using Flux Chanel, likely a specific AI image generation model within the platform chosen for its speed or aesthetic style suitable for this type of fast-paced content.
Okay, voice and image model specified. What about the assets we just sorted out?
Yep, got to include those. You map the audio URL, pulling the value from that randomized audio field we got from Sheet 2, and the intro video URL, and maybe some intro text if your template supports it, pulled from the main topics row in Sheet 1, or maybe Sheet 2.
Bringing in the music and the intro clip.
Correct. But the absolute heart of this payload, the most crucial part, is the clips section.
Clips, meaning the 15 scenes.
Exactly. This is where the power of that structured LLM output really pays off. You use N8N's expression editor to dynamically map the data from that 15-element array we got from the structured output parser.
So you loop through the 15 scenes.
Well, N8N expressions let you map the whole array. You basically tell the JSON payload, for the clips array, take the voiceover text from each scene object and put it here. Take the image prompt from each scene object and put it there. Take a visual style description and put it there. For all 15 scenes.
So it programmatically builds the list of 15 clips, each with its corresponding narration text and image generation prompt, directly from the AI's output.
Precisely. It's a rigorous automated mapping. Ensures scene 1's voiceover goes with scene 1's image prompt, scene 2 with scene 2, and so on. No manual copy-pasting, no chance of mixing them up.
That's powerful. Okay, so this huge JSON payload is built, authentication is set. Then you just execute the node.
Execute the node. N8N sends the POST request. If everything is configured correctly, JSON to video accepts the job, starts the rendering process, and usually sends back a response immediately containing a unique project ID.
Project ID, like a tracking number for this specific video render.
Exactly. You'll need that ID for the next steps. You can often check the JSON to video dashboard too and see your new render job pop up in the logs, probably with a pending or running status.
Okay, the job is submitted. But you said rendering takes time, maybe a minute or two. The N8N workflow runs much faster than that. What happens now? Does it just wait?
It has to wait, or rather, it has to check. This is a major challenge in automated workflows dealing with asynchronous tasks like rendering. If the workflow just barrels ahead and tries to grab the video file before it's ready,
it fails. The whole thing breaks down.
Right, so you have to engineer for this waiting game. This is where the workflow gets its resilience.
How does it handle the wait? Just a long pause node.
A long pause is inefficient and unreliable. What if the render finishes early or takes longer than expected? The blueprint uses a smarter approach, a status checking loop.
A loop. Okay, how does that work?
First, right after submitting the job, you put in a short wait node, maybe just 10 seconds. This prevents hammering the API immediately while the platform is just getting started, a little politeness buffer.
Okay, 10-second pause,
Then you use another HTTP request node. But this time, you change the method to get.
Get T because we're retrieving information, not creating something.
Exactly. You configure this get T request to hit the JSON to video API endpoint for checking job status. And you pass it the project ID parameter, the tracking number we got back when we submitted the job.
So it's asking the platform, hey, what's the status of project number 12345?
Precisely. And the platform responds with the current status. Maybe it's processing, rendering, running, something like that. Or maybe if it's done or completed. Or maybe error.
Okay, so now the workflow knows the current status. What does it do with that information?
It needs to make a decision. This calls for a switch node. This node acts like a traffic cop, directing the workflow down different paths based on the value of a specific piece of data.
And in this case, it's switching based on the status returned by that GetE request.
Correct. You configure the switch node to look at the status field from the JSON to video response, and you define rules for the three main possibilities outlined in the source: done, running, and error.
3 paths out of the switch node.
Okay.
What happens on the error path?
If the status comes back as error, that's bad news for this video. That path connects directly to a Google Sheets update row node.
Back to sheet 1.
It finds the row for this video, using the ID, and changes the production status column to error. And critically, it should also take the specific error message returned by the API and write that into the error log column we created earlier.
So it logs the failure, marks the idea as failed, and stops processing that one, ready for a human to review later.
Exactly. Halts the job for that specific idea, but preserves the reason. Crucial for debugging and improving the prompts or system.
Okay, that's error handling. What about the running path, if the video is still rendering?
This is where the loop happens.
Yeah.
If the switch node sees the status is running or processing, whatever the platform uses, that path connects to another wait node. Again, maybe set for 10 to 15
You can
seconds.
leave a short pause.
And then the output of that wait node connects directly back to the input of the get project status's HTTP node.
It loops back to check the status again.
Precisely. It creates a controlled cycle.
Yeah.
Check status. Is it running? Wait 10 seconds. Check status again. Is it running? Wait 10 seconds. Check status again.
Like constantly checking the oven timer, as you said earlier.
Exactly like that. This loop continues patiently until the status check comes back with something other than running, hopefully done, or possibly error.
That's a really robust way to handle the uncertainty of rendering time. It doesn't wait too long, doesn't proceed too early, just keeps checking politely.
It's efficient, stable, prevents resource drain, and ensures the workflow only moves forward when the video is actually ready or has definitely failed. That status loop is key to the whole thing working reliably 247.
Okay, so that loop keeps running check until, hopefully, the status check comes back and the switch node routes it down the done path. The video is successfully rendered.
Success. Yes, that's the goal. But the work isn't quite over. The workflow immediately needs to record that success and sort of close the loop administratively.
Back to Google Sheets again.
Back to Google Sheets, Sheet 1. The done output from the switch node connects to another Google Sheets update row node. Got to keep that ledger perfectly synchronized with reality.
And what does this update row node do?
Two crucial things. First, it finds the correct row using the ID and changes the production statuses column from for production to done. Marks it officially complete.
Okay, project closed.
Second, and this is really important, the response from JSON to video when the status is done usually includes the URL of the final rendered video file. This node takes that URL.
The link to the actual MP4 or whatever it is?
Exactly. And it pastes that URL into the final output column in Sheet 1.
So now, right there in your spreadsheet, you have a clickable link directly to the finished video for that idea.
Precisely. The spreadsheet is now perfectly accurate, showing the idea is done and providing the link for immediate access, maybe for that final human review.
That's super clean. Okay, video rendered, status updated, link recorded. Are we ready to upload to YouTube now?
Almost. The blueprint includes one final, prudent verification step before hitting YouTube: belt and suspenders.
Another check. What is it?
You add one last HTTP request node. This one is set to get T, and you point it directly at the final video URL that you just pasted into the final output column in Sheet 1.
So it's actually trying to download the video file.
Effectively, yes. Its purpose is twofold. One, it just confirms that the URL is valid and the file is actually accessible and functional, ready for streaming or download. Two, and this is key for the next step, it retrieves the completed video asset as binary data.
Binary data, not just the file, but the raw data of the file.
Exactly. N8N can handle binary data. And that raw binary data is precisely what the YouTube API node needs to perform the upload. It doesn't upload from a URL, it uploads the actual file data.
Okay, so this GE2 request confirms the file works and grabs the data needed for YouTube.
Smart.
At this point, that original spreadsheet idea has become a real, tangible, confirmed digital video asset sitting in N8N's memory as binary data.
You got it. The transformation is complete. Now, finally, the grand finale. The hands-free publishing step.
The YouTube upload.
This is where we introduce the dedicated YouTube node in N8N. You configure its operation simply to upload a video. This is the automation completing its full end-to-end journey, from idea to actual presence on YouTube.
Okay, configuring the YouTube node, what do you need to set up there?
Metadata, right? Title, description.
All that, yes. And conveniently, we have all that information neatly structured from our earlier steps. For the title, you just use an expression to pull the value from the idea column of the original Google Sheet row.
Easy enough. Description.
Same thing. You set the description field using an expression that pulls the content from the caption column of that initial topics row.
Okay. Title and description mapped. What else?
You'll want to set the category. The source suggests film and animation, or maybe education, depending on your content. Then the most critical part, the video file field.
Where does that come from?
That points directly to the output of the previous node. the HTTP GET requests that retrieve the video as binary data. You tell the YouTube node, here's the file data you need to upload. Got it. Feeds the binary data straight in. Anything else? Privacy setting?
Ah, yes, absolutely critical. The final configuration, the safeguard for quality control. Set the privacy status, crucially, to unlisted.
Unlisted, not public. Why?
Because this allows the entire automation to run idea, to render, to upload, doing 99% of the work autonomously. But the video doesn't go live immediately. It sits privately on your channel.
Giving the human operator, you, the chance to do one final check.
Exactly. You can watch the unlisted video, check the quality, make sure the caption's rendered okay, double-check the title and description, maybe schedule it for the optimal posting time. It's automated preparation, not fully automated broadcast. It keeps you in control of the final publish button.
That makes a lot of sense. Automation does the heavy lifting. Human does the final quality check and strategic timing.
That's the balance this blueprint strikes. So you execute this YouTube node.
N8N uploads the binary data, sets the title, description, category, keeps it unlisted.
And boom. You go check your YouTube channel's content section, and there it is, the new video generated from that spreadsheet idea sitting there as unlisted. Proof positive that the entire concept to upload automation is complete and functional, running hourly, churning out content ready for your final review and scheduling.
Wow, that is quite a system. #tag outro. Okay, let's just quickly recap that journey because it was pretty staggering. We started with just a single row in a spreadsheet, a raw idea, basically.
Set the line of text, yeah.
That idea gets picked up by an hourly trigger. It's expanded by AI into a detailed 15-scene storyboard with visual and audio cues.
Gets paired with randomized background music to keep things fresh.
Rendered into a polished long-form video by a service like JSON to video, complete with AI voiceover and images.
Goes through a check, wait, check loop until it's confirmed done.
The success is logged, the video file is verified and grabbed.
And finally, uploaded automatically, unlisted, straight to your YouTube channel, ready for your final look.
All orchestrated by this series of connected nodes in N8N. It's complex, yes, but as you laid it out, surprisingly robust. The efficiency gains here, I mean, compared to doing all that manually or even hiring a small team, it's just astronomical.
It really is. And the ultimate strategic takeaway here, the so what, for you listening, especially if you're interested in knowledge, scaling, how the attention economy works.
Yeah.
This kind of system fundamentally shifts where the human effort goes in content creation. You're no longer spending your hours editing timelines, managing files, clicking upload buttons.
Where is the effort spent then?
It's spent on refining the system itself. You focus on crafting better AI prompts to get higher quality scripts and visuals. You focus on optimizing the data structure in your Google Sheets for more creative control or maybe easier idea generation.
So you're managing the machine, not doing the manual labor.
Exactly. And critically, you're focused on rapidly testing content ideas at a massive scale. See what resonates, what works, without the bottleneck of manual production for every single test. The human becomes the chief strategy officer, the chief prompt engineer for their content factory.
You're not paid by the hour for editing anymore. You're paid for the efficiency and intelligence of the automation you've built.
That's the core shift.
Yeah.
And that ability to test hundreds of ideas, maintain that relentless volume and consistency without adding any extra labor hours, that's the engine of scaling that lets channels like Motiversity potentially dominate the feed and pull in those kinds of numbers.
Right. Which brings us to the final thought. If this level of automation, leveraging this strict structure, AI orchestration, specialized tools, if that can create a faceless channel apparently earning $38,000 a month just from AdSense, focusing purely on volume and consistency, it really makes you think.
It does raise a big question.
What does this highly structured, rapidly produced, automated workflow suggest about the future? About the value proposition of, say, traditional human-edited, often high-cost content versus this kind of automated approach?
Where's the balance shifting?
Yeah. In a world flooded with content, where should you, the creator or the strategist, place your bets? Is it on maximizing perceived quality through painstaking, slow human effort? Or is it on maximizing efficient structure, speed, and volume through technical automation like this?
Which type of channel, which approach is ultimately going to win the volume game, the attention game, in the next few years?
It's a fascinating, maybe even slightly uncomfortable strategic question to ponder as you look to build or maybe refine your own content engine, maybe even your own automated empire. Something to think about.